that it's in two pieces, and what I'm going to do is down the road, well, soon, very soon, is probably even tomorrow, is make another part. I'm not out of cast iron. I'm actually just going to make it out of a chunk of steel. So there's the base. There's the table over there. This drill press is Skookum. Like, it is incredibly well built. These older ones, it's a 1993. No brand name on it, but I can tell it's Taiwanese. And it's a 1 horsepower, very, very nicely built. All the finish work on it is very nice. And yeah, there's the pull for it. Yeah, the casting is very good. So I'm hoping I'll be able to fix here whatever's going to be broken here. The other thing I did too is I took the quill off. As you can see right here, the bearings were noisy. I was able to press everything out. So here they are. So I got the bearings out, so I'm going to order, and these are open bearings, so let me put this down so you can see what they sound like. Alright. I finally found my little tripod. I'm really happy about that too. Let's see. That's not going to do. So anyway, new bearings are going to be ordered. Yeah, that's going to work well, I think. I guess what I'll do is, geez, even the size of the stock is almost the same. What I'll do is I'm going to have to put a chamfer here for welding, another chamfer right here for welding, and tack them together and and weld it around, and I guess that's sort of the idea. Alright, there we go. So, yep, that's it. That's it there. And let's see, where's the matching part? Here it is. So what should happen here is these two will go together like that and weld it. Hopefully this will work, because I've tried cast iron to cast iron welding with nickel. That seemed to work fine. I don't know if it's going to work cast iron to, say, mild steel using the same nickel electrode. The cutoff that I had when I cut this off, when I parted it, I'm going to use that as a test to see whether or not the nickel will weld to it before I join these two together. And if that doesn't work, then I'll come up with some other solution. Alright, so we're back at the mill here and the drill press hub repair. So this is the setup that I got going right here. I figured this, I tried a few different things, but this looks like it might work. And so what it is, it's just basically my vise with a Spindexer and a 3-jaw chuck with a 5C backplate mounted in there, and the part clamped in right there, and the idea is to drill 3 different holes at 120 degrees apart, and then tap them. Oh shit! Fuck, did you see that? The cocksucker shattered in there. Oh no! Oh man. Yeah, obviously doing something wrong. Okay, well, now I gotta try to get this guy out of here. Oh boy. Alright, I'm back. God, the day is full of disasters. So I did manage to get that broken bit in there cleared out of that hole. It just snapped right off like you saw. I was lucky enough to save the rest of the bit. I did regrind it. So I don't know what you can see there, but it is reground. Okay. I got some oil in there and got everything reset. I don't know why that happened. I think maybe because I was messing around and things had slipped on me a little bit, and maybe I didn't get them perfectly lined up, and the bit wasn't properly centered, and who knows, it just grabbed. But I'm going to try to continue here and continue this hole and go around to the next ones and see what happens. Alright, looks like I was able to get through the rest of that. Show you what I got. 3 holes ready for tapping. Okay, bring it back later. Alright guys, I didn't film the turning or the welding of the 2 parts together, but I did turn it, and I switched over to a, a CBN insert. I can see if you can see it right there. That's just a CBN insert. Because the nickel weld, it was really hard, and the carbide was just deflecting right off of it. So the weld, I got to tell you, was really ugly. It was, I tried, 100 amps stick welding, 110, 120. The higher I got, the messier it was. It seemed to be good at around 100 amps, so I stuck with that. Even though the weld was built up quite a bit high, it looked, very similar to the weld that I did the handle weld with. So on a previous video. So that seemed to look better, but still it was really ugly. This here is the turned result. So There is some porosity in there, you know, but what I'm going to do is I'm just going to fill that. I'm going to polish it up and fill it right now, and you know, prime it and paint it, and call it done. It does look, you know, when I was turning this, there was a lot of torque on this thing, and if it wasn't welded, then it would have separated. So time will tell. I think this is going to be good. We will see. I mean, it doesn't look 100% to me, but I think it will be okay. And you know what? If this fails, then I can always lob it off, you know, and make another piece or braze it together. You know, that will work as well too. Or make a whole new part. All right, guys, got you back to the drill press. It's all assembled, and the part that I remachined right here in question has been sandblasted, painted, and installed, and it absolutely works fantastic. You can't tell that it's welded at all. It just looks perfect, and it's worked out really well. So I'm super happy about that. The drill press itself is a beast. It runs beautifully. It really does. I got a nice Japanese vise, you know, quick vise mounted on the table here. Just really love this setup. It's got a light on the side, a nice Jacobs Super Chuck. That's the setup right there. Yeah, everything is tickety-boo. And turn it on. Got new bearings in there. Really quiet. I think this drill press is going to do just great. Anyway, there you go. That's the hub repair for this nice 1 horsepower heavy duty drill press. Thanks for watching.